All right, we are building on the previous lesson, which was topic 3.1, the chain rule. So we're on the back of the page. We're going to do example 3. It's a little different. So selected values of two differentiable functions, f and g, are given in the table below. And we've seen that before, and we've used the product rule and we've used the quotient rule, but now we're going to use the chain rule. So k is a new function that is f of g of x. So we want to find f prime of 3. So what we'll do is find the derivative of k, and that's just a straight up chain rule. All right, and then we'll go back and we will put 3 in for x. All right, and then all these things we can get from our table. So k prime of 3, we're doing f prime of g of 3. We'll start and just find g of 3. So g of 3 is 6. So we would just put that 6 in there. All right, and then g prime of 3 is 2. So that's going to be times 2. All right, and then we need to find f prime of 6. So f prime of 6 is 5. So in the place of f prime of 6, we'll put 5. 5 times 2 is 10. Okay, so that's how you use the table. All right, we're also going to use the table to write an equation for a tangent line to k at 3. So we need two things. We need the slope of the tangent line and we need the point of tangency. Now we've already found k prime of 3. That's the slope of the tangent line, so we already know that that's 10. The point of tangency is just k of 3. Right? To do k of 3, it's f of g of 3. All right, so we're going to go to our table. We want to find g of 3. So g of 3 is 6. All right, so that's going to be f of 6. And then from the table, f of 6 is 4. All right, so our slope of tangency is 10. Our point of tangency is the point 3, 4. So now we're ready to write our tangent line equation. So it's y minus 4 equals 10 times the quantity x minus 3. And as long as it is free response, you just stop right there. All right, I feel like you guys might need a little more practice with that. So I made up another problem, but you're going to need to do it on a sheet of paper. All right, so for example 4, we're going to use a chart from example 3. And for A, we're going to this time let h of x equal f of g of x. And we're going to find h prime of 1. Okay, so just like before, we're going to go ahead and just write the chain rule to find h prime of x. All right, writing that will most likely get you a point if this was a free response question. And then we would want to go back. This time we have 1. Okay. And then we'll need to go back to the table. So the first thing I'm going to find from the table is g of 1. All right, so g of 1 is 2. So in the place of g of 1, I'm going to change that to just 2. All right, then I'm going to go back to the table. I'm going to find g prime of 1. That's going to be 8. Okay, so think about this for a second. What's the next thing we need to find from the table? F prime of 2. So f prime of 2 is going to be negative 2. So h prime of 1 is negative 16. Okay, and then for the b part, we're going to write an equation for the tangent line to h at x equals 1. All right, so don't forget, we need the slope of the tangent line and we need the point of tangency. And I can't tell you this will always be the case, but on this particular problem, we already know what h prime of 1 is, and it's negative 16. To find the point of tangency, we want to find h of 1, which is f of g of 1. All right, and we would start with g of 1. And we get g of 1 from our table. G of 1 is 2. So we'll put 2 in the place of it, and then we want to find f of 2. F of 2 is 2. Right? So our slope of our tangent line is negative 16. Our point of tangency is the point 1, 2. So our tangent line is going to be y minus 2 equals negative 16 times the quantity x minus 1. All right, and we're going to do one more. This one doesn't use the table. We're going to let f of x equal 5x to the 4th and g of x equal e to the 2x plus x. All right, so if h is the function defined by h of x equals f of g of x, find h prime of x. Okay, so we need to remember about compositions. If h is f of g of x, that means we take this whole g function and we're going to put it in to the f function. So that means we're going to raise it to the 4th and we're going to multiply it by 5. Okay, so now I want to find the derivative of h prime. So I'm going to use the chain rule. So this starts out as something raised to the 4th power. So that means we're going to use the power rule. So we will multiply by that power, leave the something alone, and take 1 away from the power. And then we would have to multiply that by the derivative of that something. Okay, so then I'll start doing my multiplication. So 5 times 4 is 20. All right, and then we need to find the derivative of e to the x minus, or plus x. Shoot, I messed up. I'm sorry. That should have been a 2x, 2x, 2x. All right, we want to find the derivative of e to the 2x plus x. All right, so the derivative of e to the something is going to be still e to that something. But whenever that something isn't just x, we do have to multiply by the derivative of it. Sorry. All right, and then plus the derivative of x is just 1. All right, we're getting close. So then h prime of x is going to be 20. E to the 2x, I had to fix that one, plus x to the third. All right, and then the derivative of 2x is just 2, so we're going to multiply that by the e, and then plus 1. That should be it. So that was a major chain rule problem. There's lots of stuff going on there. All right, your assignment today is going to be the circuit training worksheet.